G'day everybody. I've taken up another project, it's more in line with what I like to do. If you ever get the chance, if you happen to be looking at second-hand lathe section, and I've come across this little old gym built around the 30s, 40s, so it must have been during war years. But it's only just a very small lathe, probably 12-inch in between centres that you can machine, or 300mm. Now, looking at it, it looks like a train wreck. Bearings are loose, it's movement and everything. I'll just take you over a few things just to show you. It's quite scary, so always remember, anything can be fixed. Just you got to know how to do it. Have a look, you see here. I really don't know what's going on here. I think it might have fallen off the bearing. Hopefully that's the case, but it's sitting on the bottom. So if I lift that up there, maybe oh yes, it does. Whew. But you know, all those little things to contend with. And actually it's very surprising that it's got SKF on there, which is the modern style of bearing. Anyway, if we turn this around here, I'll show you something else. Now, it looks like this could have been used for running a shearing shed or something. There's that many pulleys on there, it's not funny. Typically, that motor and that pulley there should not be on there. So there's been addition put onto the machine. It should be really a direct drive with the motor down there, which is a newer motor of course, running off this pulley. Maybe here or there, probably it should be running off there. But anyway, I have to work out what's happening here and work out the feed rate and the revs per minute just to find out what's going on. Some of the gear teeth, which I'll show you now. I don't know if you can see that one there. No, you probably can't. Well, half the tooth is missing. I've got nothing bolted down at the moment. Well, others there, pretty worn. The feed screw, this is called the feed screw, for the typical reason of, it's not a lead screw. A lead screw is used for threading. A feed screw is for feeding the apron or the saddle. So that's all that does. Drive this up and down, so it's a feed screw. We call this a feed screw, not a lead screw. But if it had a control here, or here, where we can disengage it from here, we could do some threading on it. But of course that means that you have to get some more of these configuration cogs, because you need that for your gear train to cut your threads, which would be another adventure, because I have not found any information on the internet about this thing. A slight bit of information they think was made in Australia or New Zealand, this lathe, so it's called the Keen, and I'm always looking for information, so please hand it over to me if you want to let me know. Probably the lubrication points too. If you've got a screw in there and you have to take that screw out with a screwdriver every time you want to oil it, you're going to get wear. This is shocking. I don't know if you can see that wear, can you? Oh, we'll get a little bit. Look at that. That is terrible. Interesting, the drive on this, it's set up on a cam here, and we disengage, I'll try, there we are, let's disengage, the chuck does not turn, only the pulley. So this is rudimentary setup, it's like a dog clutch, and when you want to start again, off you go to put it in there. That's how you wreck your machine. Of course, I have already had a little bit of a secret look here. We did have a big washer on here. I don't know where it's. Oh, here it is. and it was located onto there, and I say, what the heck is that for? Anyway, I sort of think it was supposed to be locked onto here, and so you can turn it by manually, so for setting up. Well, really, do you need that? You don't need that. But working out how it's supposed to be a control here that swivels that there, and then there's supposed to be a locking mechanism that sits over this shaft here and holds it adhered to the gears so it doesn't jump out. But looking at the teeth, how well worn they are, ooh, it scares me to know. But I might be looking at how this is set up a little bit differently. See if I can change the setup so it has a direct drive coming off here from the motor onto this pulley, and doing away with this. I don't know if that'll work or not. Then I was thinking to myself, I could machine these pulleys off here and then put a V-belt configuration on top of there, probably a twin V-belt. There's enough room to make a series V-belt there on both sections and doing it that way. But you know, I think that's you could do that, but I don't know. I've got to work out. Interesting thing is I've got to work out the mirrors per minute from the gear from there to there to there. You know, it doesn't have to be spot on, but all I'm going to be doing is probably model parts with this machine. So I'm looking forward to the day when it is going, and I can enjoy the use of the lathe. I don't think there's too much work in getting it done, but it's quite interesting how things happen. I'll just give you a quick rundown on how we engage the lead screw. I'll just bring you back for this so you can see the whole operation. Okay, a little bit more back, full view. Now, this is scary. To engage the feed, we can do this. You push this lever in and just wriggle it into position, and off you go machining. So when you come to take it out, so you've got revolving gears, you've got to watch your fingers there. So it's look there, and then you can pull it out. It should work that way. Just pull it out like that and it should disengage the feed. This is an early method of feed screw control. You're feeding along the ways. It's very interesting. I don't think the bed has too much wear on it. There's a pile of rust on it and all this, but let's put it this way. I'm not going to make it a Swiss watch, but all I want is something that works right. You know, I've got lots of things to do. We're going to make a chuck key. Can't even find a chuck key for it. It's Jacob's key. I've probably got a Jacob's chuck key for here. That was another thing that I noticed before I didn't get it for a song. We should have got for scrap prices. It was just virtually, I tried to get it down, but it just didn't happen. But I think it's worthwhile saving. As you can see, as I turn this here, the chuck key revolves. So what happens there is like someone's had a go at this and they bang something in there. There is a slot in the tailstock shaft where you're supposed to line up a little pin that runs up and down, so it stops the tailstock shaft from turning. Well, that section there has been butchered, so I have to bronze it up. That's how it goes. And restart, put another thread in there. We're supposed to locate it in a little groove there, and it locks it into position. Somehow it's not working properly. So that's another thing that I have to check out on the tailstock. Some of the interesting things about it, the hole through the back of this is about 3/4 of an inch. So, you know, it's capable of doing a little bit of work. I don't want to do anything bigger than, well, the chuck is a 4-inch chuck, so it can do some work, but what I mean is what you're driving, you don't want to be overstressing it. I'm thinking for the lubrication points here, And here, having controlled drip feeders in there, because it's got to have a certain amount of oil going into those and all that. And then we got the drive on the belt. As you can see, that's the speed it rotates at. Well, one of the speeds. Then we engage this. We engage that. Okay. Then you see this going faster. This is going much slower. So we've got the shaft turning upon. We've got a bore turning on a shaft, going at two different speeds. So we get excessive wear there too. And they got lubricating points, but the one up here that the belt was originally on is blocked. So it hasn't had any oil into that section for years. So, you know, these things will go forever more if they are maintained. Obviously, it's been treated like a train wreck and probably over emphasised in what it could do. Because I happened to spy a billet there, a 4-inch billet, which they would have had in here, but I couldn't see the chuck key that they used to tighten it in there. That's what they were trying to machine. Now, everybody knows these machines here with their cast iron, hopefully there's a bush inside there, the shaft is not worn and is sacrificial, which would be a bronze bush, sintered bronze or something like that, are in these, which you can adjust down with these things here if you need to tighten. I did check it, and there was about 4 thou movement indicator here, so I thought I'd just adjust it, see what happened. I just gave a little bit and, you know, took the adjustment out there. So what I mean is, when you do all these things, there's little inspections that you have to do on these machines before you start using them. They are fun, as long as you don't get your clothing or your hair or anything wrapped in these. These are fun. Be careful while giving it a go to fix up. I don't think it's going to break the bank to fix it, probably $300 or $400. I'll get it up to scratch. Nice clean up, clean down, strip down, clean up. Put it all back together. I know a lot of things are not up to scratch, but nor is landing on the moon up to scratch. So we can certainly enjoy this build. I will. Well, it depends how much it's going to cost me to get it fixed. Hopefully I don't have to do too much work on the bushing or the shafts, more so the shafts. Bushings are not too much of a worry for me. It's the shafts and all that, the wear in those. Because I've got a funny feeling, you know, I'm waffling on a little bit here, but I happened to sneak this piece off here, which I managed to get to here, so I could get this crazy thing off so no one could see how it was set up. And that's all I got a little bit forward. So I pulled off the shaft, and I can see there's a steel bush that's been put onto the sprocket. Now, that back yarn's manned for an answer for a bush, where you use a steel bush to go onto, rub onto a steel shaft. It's not really what should happen. You should, if you're going to run one of these lathes, you don't make a quick fix. You've got to do it properly, and it'll last you a lifetime. So I've got to get this train wreck, I'll call it a train wreck, back into some recognition, and I am certain I will get close to it. That drive setup, it's just a little bit over the top there, although it's nice that it's set up like that, but it's like it's operating a shearing shed, don't you think? Anyway, I'll leave you with that, and I'll start pulling it to bits. I'll start off with the gear, with the lathe first. I'll take some measurements because I want to shorten this bed because it's ridiculously long. I'll just shorten up here and there. I've got plans to make up a swarf tray for it and see if I can tidy it up and make it look like a hobby machinist lathe again. That's all they were. And actually, for them to be built 1935 to 49, right through the war years, and they're virtually only just a hobby lathe, it really surprised me, unless they had a specific reason why they built them. But this one has had a bit of a hiding for it to find out what is good and what is bad. As long as the bad's good, which it looks like it is alright, it hasn't done too much work, although it does worry me that the feed screw is a little bit worn. That means that the engagement nuts in here are damaged. Alright, we'll carry on. It's come to start pulling this apart. Bit of nostalgia here. Old switch off and on, but I'm sure I didn't just have one piece of coming in and out of there. I could have. See how it was set up. Righto. I like Cookie Monster just nibbling away on this thing. I'll stop off first. Let's see what sizes they've got. If they are width worthy, we'll use a metric spinners at the moment. 15-16 seems to fit it. Nut seems to be in pretty good condition. Thread looks fine. That's a start. Things like half the coupling is missing, so little things I have to make up, which can be made up at no problems. I don't know if you can see that. A little keeper just sitting there floating around. Oh, there you are. At least it lines up so you can get at it. Well, it's missing the other side. That's all right. Try and put everything back together so we don't lose things or mislay things. This tailstock is non-adjustable, so it should be in perfect alignment. I suppose there'll be a little bit of wear with it. You're not expecting miracles. Okay, I'll just carry on here, strip it down, and sometimes I'll bring it back. I just put this up here for display to show you how roughly what it looked like when I bought it, so you can follow it through. So I'll just remove all that stuff, put it out of the road, and then I'll start off with something easy. Take the tailstock off, already taken out the piece of thing here which has been shoved in there. Looks like that's got to be built up and recentered.